Hey everyone, and welcome. Have you ever stopped to think about how you can create your own private, secure little corner on the huge, wide-open internet? Well, today, that's exactly what we're going to break down. We're diving into the tech that makes it all possible, the Virtual Private Network, or VPN.
So let's start with a really basic question. When you're online, say at a coffee shop or even just at home, is your connection actually private? The short answer is no, not really. You're on a public network, and that means other people could potentially see what you're doing. And that's the big problem we're here to solve.
And the solution? That's where the VPN comes in. Honestly, the best way to picture a VPN is to think of it as your own personal, super secure tunnel. A tunnel that you build to go straight through the public internet, shielding all your data from a world that frankly wasn't built with our privacy in mind.
All right, so what is a VPN, really? It's a technology that builds a virtual private connection. We call it virtual because it's literally using the same roads as the public internet. But, and this is the important part, it's private because all the data zipping through that connection is encrypted, which just means it's scrambled into gibberish for anyone trying to snoop. And this image here, it does a great job of showing you exactly what I mean. See how you've got a mobile worker, a home office, and a whole regional office. They can all securely link up to the main corporate site. They're all using the same public internet as everyone else, but the VPN builds these private tunnels, making it feel like they're all plugged directly into the same secure, private network. Pretty cool, right?
Now, VPNs generally come in two main flavors. Over on the left, you've got a site-to-site VPN. This connects entire networks together, like linking two different company offices. And here's the kicker. Your computer doesn't even know the VPN is there. The network gateways take care of everything behind the scenes. Then on the right, you've got a remote access VPN. This is probably the one you're more familiar with. It's what you use when you connect from home. You, the user, actually have to click a button to start the connection and get secure access.
Okay, but how in the world do you build one of these secure tunnels? I promise, it's not magic. It takes a very detailed, standardized plan, a blueprint, really, that both ends of the tunnel agree to follow. It makes sure they're both speaking the exact same secure language.
And that blueprint, the industry standard set of rules for building these powerful VPNs, is called IPsec. That's short for Internet Protocol Security, and it's basically the instruction manual for our private tunnel.
You know, this slide really nails a key point. IPsec isn't just one single thing. It's more like a framework, kind of like a menu at a restaurant. It tells you the courses you need, an appetizer, a main course, a dessert, but for each one, it gives you a bunch of different options to choose from. This makes it incredibly flexible and super powerful. Okay, so we've got our blueprint, IPsec, but what are the actual tools in the toolbox that we're going to use to build this thing? Let's open it up and look at the 4 essential functions that every single secure VPN is built on. First up, we've got confidentiality. And this one is exactly what it sounds like. It's all about keeping your data a secret. Think of it like an armored car. You don't want anyone on the street to see the valuables inside, right? So you tint the windows. Well, in our digital world, we do that with something called encryption. And that digital window tint is our encryption algorithm. As you can see here, there are some older options, but today, the absolute gold standard is AES, the Advanced Encryption Standard. The real game changer is the length of the key. You can think of it like the complexity of a lock. A longer key, like the ones AES uses, just makes that lock exponentially harder for anyone to pick. It's what provides true confidentiality.
Next up, we need integrity. See, it's not enough for your data to just be secret. You also have to be 100% sure that it hasn't been changed or messed with along the way. This is kind of like putting a tamper-proof seal on a package. You want to know if anyone has tried to open it before it got to you.
We get that guarantee by using something called a hashing algorithm. Again, there are older ones, but the modern standard is SHA, the secure hash algorithm. A hash basically takes all your data and creates a totally unique digital fingerprint for it. And here's the really cool part. If you change even one tiny bit of that data, the entire fingerprint changes completely. This is how you know for sure that the message you received is exactly the message that was sent.
Tool number 3 is authentication. I mean, this just makes sense, right? Before you even start building this secure tunnel, both sides need to prove who they are. You can't just let anyone connect. It's like a security guard at a top secret facility. They're going to check your ID and make sure you are who you say you are before they even think about letting you in. So IPsec gives us 2 main ways to prove our identity. On the left is the pre-shared key, or PSK. It's the simple approach. You just give both devices the same secret password ahead of time.
It's like a secret handshake, and it works great for small setups. But on the right, you have a much more powerful method using RSA and digital certificates. This works like a digital passport. Each side has a certificate verified by a trusted authority to prove its identity. It's way more scalable and secure for bigger networks.
And that brings us to our last tool. And it might just be the most clever one of them all, Diffie-Hellman. Okay, think about this. We need secret encryption keys to lock up our data. But how did two devices talking over the public internet agree on a secret key without an eavesdropper just listening in and stealing it? It's like two guards needing to agree on a secret passcode while standing in a crowded room. How do they do it?
And the answer, believe it or not, is the Diffie-Hellman algorithm. It's a truly brilliant bit of math. As this shows, two people can exchange some information out in the open, in public, and through a really clever process, they can each come up with the exact same secret key on their own. The secret key itself is never actually sent across the wire. It's an incredible breakthrough that really makes secure communication on the internet possible.
All right, let's take a step back. We've got our 4 tools: confidentiality to keep it secret, integrity to keep it real, authentication to prove who's talking, and a secure way to create our keys. Now, let's put it all together and see what happens to our data as it takes a trip across the internet.
So your computer wants to send some data through the VPN. It takes all those tools we just talked about, all of the choices you made from that IPsec menu, and it gets to work. And boom, this is the payoff right here. Look at this diagram for tunnel mode. Your entire original packet of data, your actual information, your original IP address, all of it, gets encrypted first. Then it's wrapped up inside a totally new IP packet. The only thing anyone on the public internet can see is a meaningless packet going from one end of the VPN to the other. Your real data and its real destination, completely invisible, tucked away inside this secure armored shell.
It all comes back to this one simple idea. We call it a private network because that encryption is what keeps our data confidential. It lets us build our own secure highway right through the middle of an untrusted world.
So we've gone through the whole process. We've looked at the blueprint, we've laid out all the tools, and we've seen how a secure tunnel gets built piece by piece. So the only question left is for you. Now that you know how it's done, what are you going to protect with it?